everyone, my name is Tiffany and today I'll be demonstrating a filtration experiment. A filtration experiment is usually done when our objective is to separate an insoluble solid from a liquid. The materials I will make use of in today's experiment are a clear glass representing the beaker, a funnel as the filter funnel, coffee filter paper as my filter paper, water as the solvent, and tea leaves as the solute. So first, we put the funnel right above the opening of the glass and insert the filter paper. Once we do that, in a separate bowl, mix water and tea leaves to form the solution. Secondly, pour the solution into the filter funnel and observe it. As we can see, now in the glass we have collected a clear yellow colored liquid, also known as the filtrate. And in the filter funnel, we have collected the remaining tea leaves, also called the residue. Why is it that the leaves in the funnel are not able to pass through and flow into the glass? Well, this is because the filter paper consists of many small holes that only allows molecules small enough to pass through. The water molecules and the tiny tea molecules can pass through the tiny pores of the filter paper, while the big leaf molecules have a size bigger than the holes on the filter paper. This causes them to be trapped on the filter paper, giving us the residue. This is one of the many techniques of separation. I hope this video was helpful. Thank you.
I will be conducting an experiment demonstrating Brownian motion. The materials you will be needing for this experiment is 1 glass of hot water, 1 glass of cold water, and iodine. First, put droplets of iodine into the glass of cold water. Now, put droplets of iodine into the glass of hot water. As you can see, the iodine particles are suspended in the cold water and do not dissolve as fast compared to the hot water. This is because water is made up of particles that are constantly moving. When the particles are heated, they gain kinetic energy and vibrate more vigorously. Thus, the particles will collide with the iodine particles and the iodine will spread faster. Thank you.
So step number 1 for doing the paper chromatography, you first need a 15 by 10 centimeters paper, and make sure you draw 5 lines of equal distance, and after that you want to draw another line here. This is called the pencil line, and an important note is that you should use a pencil to draw the lines, as anything else can get mixed up with the water and make a difference in it will be wrong. And now you want to draw your colors here on the middle of each line. Here I have 4 colors: pink, orange, and purple. Why 4? Because the last one will be multiple colors, or 2 or more colors. So these are the markers. This is a mix of pink and orange, and yeah, you can use any color dye. You can use color dyes, markers, or paint, or even paint. I'm using markers because they're the easiest. What you want to do is prepare a glass with very little water in it. A note is that your pencil line should be above the water level. So you just want to compare it, and if it seems as if it's higher, then it's good. What you want to do is to put your paper and dip it inside the water. And now we wait. So it has been about 30 minutes, and this is what it looks like now. This is the mixed color, and you can see it it goes up. The color goes up. This process takes a very long time until you actually see the full results, but this is what is to be expected, and that's it.
Chem project. I'm going to do paper chromatography. Usually we use filter paper, but since we're at home, I'm gonna use napkins because paper does not work for me. Anyways, we need markers, making sure that that's not for watercolor, and a glass of water and some dyes. Now make a line about 1 centimeter from the bottom and the top using a pencil, and make a dot using the dye in between the line. Now fill the jar with some water and dip the paper in the jar, making sure the water does not touch the line. Now we wait. Okay, done. Make sure pull the paper before it reaches the top line and dry it. And now you can see how many colors are in one dye. That's all. Thank you.
video, we're going to talk about the group 17 elements from the periodic table, specifically their individual reactions with hydrogen and the relative stabilities of the hydrides in terms of bond energy. The equation shown on the screen is the general equation followed by all group 17 elements when reacted with hydrogen, where X is the group 17 element and HX is the product. Some examples include hydrogen chloride, hydrogen iodide, hydrogen bromide, and hydrogen fluoride. HF reacts explosively in all conditions. HCl reacts explosively in sunlight. HBr reacts slowly on heating, while HI forms an equilibrium mixture on heating. The thermal stability of group 17 hydrides, otherwise known as halogen hydrides, decreases down the group because of three factors. The first one is because the size of the halogen atom decreases down the group. Second is because the nuclear attraction decreases. The last one is because the HX bond becomes longer and weaker as bond energies decrease down the group. This means less energy is needed to break the bond.